Hello everybody, in this video we're gonna work together on a geometry generation using GMSH. So the geometry of our interest is included in an OpenFOAM tutorials folder. So I'll open the tutorials of OpenFOAM and I look for the keyword Throttle. Okay, so it's included here in this folder, so I'll copy it in my working directory. So here it is, and I'll run. Okay, so I'll open this. I'll run block mesh to generate the mesh. Then I'll run ParaFoam to show you the geometry that we're gonna work on. So this is the geometry we're gonna generate using GMSH. So this is 2D geometry with a structured mesh. So we're gonna see together how to create vertices, to create lines, how to assign your boundaries of your geometry, how to define surfaces, physical volume, and also how to convert the GMSH mesh to an OpenFOAM readable format. So let's start. So you can see here that this mesh is generated using block mesh dicts. So here is the coordinate and all the other setup, but we're gonna do this in GMSH, and you're gonna see that it's much easier to use the graphical interface of GMSH to generate the mesh, and also it's much easier to manipulate the mesh parameters and so on. Okay, so here I'll run GMSH, okay, and I'll create a new file named .geo. Okay, so here it creates an empty file called throttle.geo, and this file gonna be updated each time I'm executing a command in GMSH. So here we'll start with the points or the vertices creation. So here in modules, geometry, elementary entities, I'll click on add and add point, and here we need to define the first point of our geometry. So I'll keep the geometry open in ParaFoam so we can pick the coordinates. So it's activate the grid. Okay, so we'll start with the first point here. So this is the first point here, but here we have convert to meters, so all the coordinates here are multiplied by 10 minus 3. Okay, we can start by introducing this point here. So in GMSH, so my first point x value is equal to 0 and y value is equal to minus 0.0025 and click add. You can see also here, move the mouse to enter coordinates. So press shift to hold position, E to add point, and Q to abort. So here we're gonna introduce the other point, this point here. So x is equal to 0.005, the y is equal to minus 0.0025. So add. Here I have my second point. Then our third point, which is here. So for the x value is 0.007, y value is minus 0.0025, and again add. Then for the fourth point here, it's for the x value it's 0.017, the y it's minus 0.0025, and add. Okay, so I'll press Q to abort, and here you can see my point 1, 2, 3, and 4. So here, if you go to the created file of our geometry, we can click on reload, and here you're gonna see that we have a script for each created point. So I prefer to remove this lines, it's just comments. Okay, so here we have 4 points. We can do the same, for example, to create without going here in the interface and create the other points. For example, I'll create the point 5, which is here. Which is here, in fact. So 0.5, 6, 7, and 8. Okay, so I'll create the next 4 points, not by using the graphical interface, but just by using this. So I'll name them at first 5, 6, 7, and 8. And for the coordinates here, so for the it's the same x coordinate. So to get the coordinate of this point, the y coordinate, so we'll go here and the block mesh, so it's 0.15 multiplied by 10 minus 3, so it will be 0.00015. So the same for the other points, because it's the same y coordinate. Okay, so here let's call this the first line of points, or the first group. Let's call it like this. First group. This one is second group. Okay, and here we need to press save and go to GMSH. So here in this option we need to click on reload script, and here you can see that we have our points, 0.5, 6, 7, and 8. It's created. Okay, so now we're gonna create the third group of points, this point 1, 2, 3, and 4 here. Okay, for the x coordinate will be the same. For the y coordinate will be equal to 0.15 multiplied by 10 minus 3. Okay, so I'll go to this, copy, paste, and this will be our third group. So this will be 9, 10, 11, and 12. So I'll just delete the minus sign. Okay, save. Then in GMSH, reload script, and you can see that we created the third group of our points. Then the same thing to create the last group of points. Okay, the fourth group. It's 13, 14, 15, and 16. So for the x also it's the same, but for the y coordinates it's 0.0025. Okay, click on save, then GMSH, reload script, and here we have our points. So now we're gonna add lines. So here in add, geometry, elementary entities, add, and line. So we'll click this point with this point, then this point, this one. Okay. And we will form our geometry with the created points. So here you can see that here we have already, so I'll abort because I've created what I want, and here we click reload, so you will see here the lines creation. So we have different lines here. I'll just delete the lines of comments. So you can see here that we've created 16 lines in our geometry. So here we have our geometry. So then I can do, for example, create a surface. So I'll go and create planar surface by considering all the lines by default. Then click Q abort. So here I have lines and surface. You can check this by going here, tools, visibility, and here you can see the curves and the points. For the physical groups, we don't have any physical group, not yet. So to create a surface, we need to go here in plane surface, and we need to select the lines and then press E in order to create our surface. So here you can see our surface. So to check its visibility, we'll go here in tools, visibility. Then you will see that here we have one surface, 16 lines or curves, and 16 points. Okay. So here I'll choose all and apply to keep all okay, and then here we can generate our mesh using just this shape or this geometry. How to do it? Just go here in mesh, then do 2D mesh. So this is an arbitrary mesh, so you can see that it's not structured, it's not uniform, it is done arbitrary. Okay, so this is not what we are looking for. This is not what we need to do our geometry. We need a structured mesh. We need a structured mesh like this one. So what we need to do is to go here and define surfaces. It's like subsurfaces to give our code more constraints in order to get what we want. Okay, so here I'll reload. So here you can see that we've created surface and we check the visibility. It's all written in the .jo file. Okay, so now what we need to do is we gonna remove the created surface at first. So the lines of the surface creation, this one and this one, and this is not very important for us. So I'll delete these lines and I'll make here reload script, so we can check again tools, visibility. So here we don't have any surface, any defined surface, because we deleted the created surface from the .jo file and we clicked on reload script. So in order to get a structured mesh, we will create subsurfaces or blocks. So instead of working on the wall geometry at a time, we gonna define subsurfaces or blocks of our throttle so we can generate a structured mesh. So we will go here in add line and we will add extra lines. So this line, this line, this line, and also here the small nozzle will be a block, separate block. Okay, so now what we press Q to say to the code that we are done. Okay, so here I have extra lines. So here I have extra lines defining my created blocks. So now what we need to do, we're gonna go on mesh, then define, and we will choose Transfinite curves. So Transfinite, what is Transfinite in fact? It's like imposing, you are obliging the code, you are telling to the code that, for example, in this line from this point to this point I want to define 2 cells, 2 partition, or 3, like here you can see that we have 3 partitions. So you will tell GMSH that here, from here to here, I want 3 lines. Then the number of columns, okay, you will, for example, from here to here, say that I want, for example, 50 columns. So this is the Transfinite idea of the curve integrated in GMSH. But before, we need to define the created surfaces, the subsurfaces, the new blocks defined. So I'll do add plane surface, then here, so this is the first surface. I selected the lines creating my new surface and I'll press E. Then I select for the second one, third one. So you can see this sign. This is the sign that we've created the surface. Okay, press E. And the last surface, press E. Then I'll press Q to abort because I am done. Okay, so now I have my surfaces. So you can see here that we have first surface to the seventh one. Okay, so I'll go and do the Transfinite curve. So it's not in geometry, it's in mesh here, and mesh, define Transfinite curve. Okay, so and I'll choose this one, this one, this one, and this one, and I'll tell the code to make a tree partition in this direction. Okay, then I press E. So I defined here the number of partition in this side, this line, and this line. So it's updated here. I am transfining curves 15, 21, 22, and 7. But here I'm adding more lines to my code. I can do something better, which is copy, for example, here. For example, in the Transfinite curve 15, so I'll go to C line 15 and do this Transfinite. Okay. Then do the same for the other ones, 21, 22, and 7. Okay. Then I'll delete this line since I've defined the Transfinite property according to each line. So save. Then here I'll go to geometry, then reload script. Okay, so everything is okay here. Then now we want to assign the number of partition in this part, this one, this one, this one, and it will be the same since it's symmetric for the other parts. So for the number of points, so here I choose mesh Transfinite curve. This one, this one, this one, also this and this, and here, for example, I choose the number of 20 or 22. Let's make 22. Okay, and I press E. Then I choose this one and this one also, this one, and I'll choose 50, for example. You can choose the number of divisions of your interest. If you need a refined mesh, you can choose much more, and if you need a coarse mesh, you can choose, for example, just 10 lines to 10 columns. So it depends on your need, on your computational resources, and on your case. Okay, so then I'll choose this line, this line, this line, and I'll define to divide them by 10. Then I'll press E. Okay, and in this zone I'll define, for example, 10 partition, and I'll press E, then Q to abort. So here reload. Okay, so I'll copy it in the line 16, line 2, 4, 6, 8, 10, 12, and 14. And of course, I need to delete the other. So this is just an organization point. So you can keep it as it was here in Transfinite curve for different lines from these. Okay, so here we can go and do reload script. Okay, so now after assigning the number of partition of each line, we can go and do, for example, here the mesh 2D, and you can see it's true. You can see that here, if you count, you will find the number of cells already chosen by our algorithm, our code. So now what we need to do is to go in mesh, then choose Transfinite, and then surface. And here we should select the first surface, then press E. The next surface, press E. This one, press E. Okay, so here, this one also, and this one. Okay, so now what we're done, I'll press Q and I'll check my code if everything is okay. So I have Transfined surface 1, 2, 3, 4, 5, 6, and 7. So I have all the surfaces Transfined, and we can press. So here you can see that we have squares, but it's divided on triangle. So what we need to do is to add an extra command in the last one, which is Recombine Mesh, and we need to choose all the surfaces then press E. So it's here, recombine surfaces from 1 to 7. Then to upload our, to update our mesh, we're gonna click on 2D, and here you can see that we have the number chosen of, the number of division chosen for each line. Okay, so here you can see that for this line, for example, I have only 2 divisions, while I am choosing 3 divisions here. So just take it as a rule in GMSH. You need to, if you want 4 divisions, choose 5 in order to get what you want. I don't know what's going on inside, why it is given this, how it is programmed, but if you need, for example, 3 division, choose 4, and so on. So here I'll instead I'll keep this in this way. Just instead of 3, I'll make 4. The same here, 4, 4, and 4. Okay. Then reload script 2D mesh, and you can see that we have our structured mesh. So this is very coarse. I choose here 10, but I'm getting only 9. So I choose, for example, 15 instead of 10. I'll choose 15, so reload script. Yes, because I choose 15 in the upper line, in this line. This line I choose 15 divisions, and this one is kept equal to 10, so it can't be a structured mesh. So I need to upload the other one too. So this one must be equal to 15. Okay, then reload script 2D, and here it is. Okay, so this is our mesh. We can refine more here if we need. Just increase the number of divisions in these lines, then the number of divisions here also, and you can refine the mesh the way you want it. So now we've done our 2D mesh. We need to extrude it in order to generate volumes, because OpenFOAM, it works on 3D geometries. It works on volume. For example, if you want to assign 2D geometry, you need to make it 3D geometry and tell to the code that in the third direction I have just one cell. So here, what we need to do is to go on geometry, elementary entities, then extrude, and extrude Z. So I'll check the Z. So for the Z, the delta of Z is equal to 0.0003. So I'll make the same. So in the Z direction, it's 0. Okay, for the mesh layers, how many layer? So I'll keep it equal to 1 layer. Extrude my mesh. Then I need to select my surfaces here, all the surfaces. Then I'll press E to tell that I'm done, and Q to finish the operation. So here you can see that I have my generated mesh. Okay, and you can see it here in the .geo file. The number of layers, it's 1 because it's 2D, only 2D, and the coordinate of Z, extrusion, and recombine in order to keep the mesh in the front and in the back conformal. Okay, so now we need to create our physical surfaces, because the created surfaces, the surfaces that we've already created, are geometrical. It's done in order to get the mesh done. But if we want to create a physical surface, we need to go here in physical group, then add surface. So I'll start by doing the first one. So add surface, the front and the back. So we can go here, properties, and see the names proposed here. So the names suggested here, I have front and back. You can see the layers in the front and in the back. Then the inlet, it's in this side. The outlets in this side. Then walls, the other boundaries. So we'll do the same, in fact. I'll start by the front and the back. Front and back. And I'll choose the geometries, the surfaces. Okay, so choose this one and this one, this one, front and back. Okay, so now I've choose all the surfaces that creates my physical surface front and back. So I press E. Okay, so now it's done. Now I'll go and create the inlet. Name inlet. It's very simple in GMSH to create physical groups. So this is the surfaces that define my inlet, and then I'll press E. And for the outlets, it's this one, and this one. I'll press E. And now for the walls, I'll name it walls. So the same name is here, so it's walls. Okay, so this surface, this one, and the top, and in the bottom, this one. Okay, so here are my walls. I've forgotten this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, then I press E. Then I'm done. I press key Q to abort. So here, reload. Here I have my physical surfaces created, front and back, inlet, outlets, and the wall. So now we have all the surfaces, but we need a volume, because OpenFOAM, it works with a cell zone, so it needs a cell zone to launch the simulation. So the same way here in the physical groups, we will go and choose volume, and we will name it, for example, volume with uppercase like this. And I choose all the sub-volumes. Okay, it's done. And here, reload. So here I have my volume, I have my mesh. I think everything is done. So now we have created the physical volume for the cell zone. Here we have our 2D, then we have our 3D mesh. Now we can go and extract, save our mesh. Export. And here I'll save it under the name .msh. Okay. Replace it. And here it's very important to choose version 3, because the version 4 is not supported by OpenFOAM, so you need to extract your mesh on a version 2. Okay. Then here you can see that we have a generated file called Throttle.msh, and we gonna work on this file, in fact. So I'll create here a new folder. I'll name it GMSH Throttle, and I'll copy my mesh in this folder, and I'll copy also 0 constant and system here. Okay, so I'll remove the polymesh and I generate so here I go to the created folder GMSH Throttle, and here I'll convert the created mesh to OpenFOAM mesh. So by doing GMSH to foam throttle, so it's done, and I go and do ParaFoam. And this is our geometry created using GMSH. Okay, so this is the front and back. This is the inlets, the outlet here, and the walls. So this is our created geometry. So we can go and check here in polymesh boundary. So here we have front and back. It's type patch. We need to modify it to type empty. Then inlet patch, it's okay. Outlet also, but walls must be type of wall. So now it's done. We can go on ParaFoam again, click apply, and you can now run your simulation using your created geometry. So this is for the throttle in 2D. You can instead go and create furthermore a 3D geometry of the throttle. So here we have, instead of extruding for only this surface, for example, we can choose it equal to 0.05, and the number of layers, for example, I'll make 15. Okay, and I'll click save. Then in GMSH I reload script. So here you can see that we are generating a 3D throttle. So 2D, then 3D. Okay, so let's see. So you can see here the generated mesh. And you can work on this. So files, export, and I name it throttle 3d.msh. Okay. Version 2. Okay. So here we've created a new one. So I'll copy this one and I'll rename it "3D", and I'll put my mesh here. I'll delete this one, also the mesh here. CD GMSH throttle 3D, then GMSH to foam 3D mesh. Okay. Okay, then we need to constant polymesh boundary. We need to modify the front and back to type empty. So the front and the back here won't be empty, in fact. because it's not 2D anymore. It will be wall. We can change it to wall here. Patch was to wall also. Okay, and here I'll go and run ParaFoam, and here you have your geometry of throttle extruded, not for 2D but for 3D geometry. You can visualize it with edges in order to investigate the resolution. You can refine it more using your code, so you can modify in here, or you can go and add what you want in the graphical interface. So this is all for this tutorial. Thank you for watching and hope everything is clear.